Okay, so I'm going to finish up 3.6. If possible, I'll sneak in a little bit of 4.1, which is a review of trig. Okay, tomorrow I'll have question and answers. So whatever questions you want, bring it up tomorrow. I may decide to do my own review anyway. I'm going to give higher priority to questions that I did not already do. Sometimes on review day, people ask questions that I already did. I mean, I'm not totally against it, but if there are problems that people have which we did not cover, I'd rather do those rather than go back and redo ones that I already did. You can always look that back up in the notes or in the videos. Okay. All right, so we should be on par. No changes to 3.6. So this is what you have to turn in on Friday for the test. Okay. All right, so let me see how far we can get. Hopefully this thing won't break down on me. So this is where we were yesterday before my document camera broke down. So this was a long division. Maybe I'll just show it to you. And I tried to say it to you at the end. So if you do the long division, you can follow along. Look at the video if you need to. X squared minus 2x minus 3. That factors into this. So x squared plus 1, x plus 1, x minus 3. Okay, so the full factorization is x plus I, x minus I, x plus 1, x minus 3. And the zeros are plus or minus I, negative 1, and 3. Okay, it was a fourth degree polynomial. So if there's a fourth degree polynomial, there has to be 4 zeros. And here they are. Okay, so now you can see it, and hopefully it's on the video. So I'll go back and do some more problems now. All right, I was going to show you 3.649. Okay, f of x equals x to the fourth minus x squared minus 2x plus 2. So what are we trying to do? Find all the zeros of the given function. Okay. Now, usually the easiest thing to try is 1. Okay. If I plug in 1 right away, you should be able to tell that it works. I have 1 minus 1, 0, minus 2 plus 2, 0. Okay, so that means I should try 1. Okay, so 1, 0, because there's no x cubed. Negative 1, negative 2, 2, right? So we played that game before for synthetic division. I'm expecting a remainder of 0. Okay, 1. Multiply, 1 times 1 is 1. Add 1. Multiply, 1 times 1. Add 0. Multiply, 1 times 0, 0. Add negative 2. Multiply, 1 times negative 2 is negative 2. Add 0. Okay, so how do I read this? Numbers, x is x squared, x cubed. So this tells me x minus 1 is a factor. X cubed plus x squared plus 0x minus 2. Of course, when you write the polynomial, normally you just write x cubed plus x squared minus 2. But when you do synthetic division, you got to put the 0. Okay, I notice 1 works again. You can tell right away if you plug in 1, right? 1 plus 1 is 2. 2 minus 2 is 0. So I decided to do another one. So in other words, 1 will be a 0 of multiplicity at least 2, maybe even more. Okay, so 1, 1, 0, 2. 1 again, synthetic division. So add 1. Multiply, 1 times 1 is 1. Add 2. Multiply, 1 times 2 is 2. Add 2. Multiply, 1 times 2 is 2. Add 0. All right, so I now have x minus 1 and another x minus 1, okay, which is x minus 1 squared. This gives me x squared plus 2x plus 2. Once I get to a second degree polynomial, I can always use a quadratic formula, which I'm going to do. All right, so a is 1, b is 2, c is 2. So x is negative b, negative 2, plus or minus the square root of b squared. 2 squared is 4, minus 4 times a, which is 1, times c, which is 2, divided by 2a, 2 times 1. Okay, this is 4 minus 8, which is a negative 4. If you can't read that, that says negative 4 up there. Maybe I'll try to write it a little bit. Negative 4. So negative 2 plus or minus the square root of negative 4. Negative comes outside, becomes an I. So I have I radical 4. Well, radical 4 is just 2. So negative 2 plus or minus 2i over 2. Divide each of these by 2. I have -1 plus or minus I. And as we already knew and we anticipated, the zeros that are complex come in conjugate pairs, right? -1 minus I, -1 plus I. Okay, so way back to the beginning, we had fourth degree. We're supposed to have 4 zeros. Here are the 4 zeros. 1 of multiplicity 2, or you can say 1, 1, and then 1 minus I, 1 plus I, conjugate pairs. Okay, and then the total factorization, factor completely, well, x minus 1 squared, that gives me multiplicity 2, and then x minus each of these guys would be x minus parentheses 1 minus I, and then x minus parentheses 1 plus I. And you can just leave it like that. You don't have to go any farther with that. Okay, then the problems at the very end, 51 through 55, find a polynomial with a leading coefficient of 1 that satisfies all the given conditions. So they tell you the degree and then something about the zeros. Okay, so I'll show you a couple of those and then I think I'm done. Okay, for 51, it says the degree is 3, the zeros are 2 and 2i, right? And since we know complex solutions come in conjugate pairs, if 2i is a solution, automatically -2i is also a solution, or a 0. Okay? So third degree, there's supposed to be 3 zeros. Here they are, 2, 2i, and -2i. Okay? So that tells us how to build a polynomial. Right? So we just go x minus each of these. So x minus 2, x minus 2i, x minus a minus 2i, which is x plus 2i. Okay. So they told me again the zeros are 2 and 2i. There's one more. But since complex roots come in conjugates, the conjugate of 2i, that's like 0 plus 2i, would be 0 minus 2i. All right, so I multiply these two together. This looks like a minus b, a plus b. So that's x squared minus 4i squared. There's I squared giving me -1, right? So that's x squared minus 4 times -1 is x squared plus 4. So now I just multiply x minus 2 times x squared plus 4. And final answer, x cubed minus 2x squared plus 4x minus 8. Okay, so here's a polynomial, third degree. It has 3 zeros. They are 2, 2i, and -2i. All right, then I want to show you 55, and then I think I'm done. Degree 5. 0 of multiplicity 2 at -2. 0 at 0, and 0 at 1 plus 2i. Okay, so degree 5, I'm supposed to have 5 zeros. 2 of them are -2, multiplicity 2, so that's 2. Third one at 0. Fourth one at 1 plus 2i. There's one more. The last one is the conjugate of 1 plus 2i, which is 1 minus 2i. Okay, so how do I build it up? I have multiplicity 2 at -2. That gives me x plus 2 squared. Okay, so x plus 2 squared. Okay, that gives me -2 multiplicity 2. A 0 adds 0, that means x, or x minus nothing. And then x minus each of these. It gets messy, but it's bracket x minus parentheses 1 plus 2i, and then bracket x minus parentheses 1 minus 2i. Okay, so the last task is to multiply all that junk out. Okay, first I decided to multiply that. So x plus 2 squared is this, x squared plus 4x plus 4. I still got an x. Okay, to make this easier to distribute, I decided to go x minus 1 minus 2i, x minus 1 plus 2i, and I grouped it like this. See what I did? X minus 1 minus 2i, but I'm putting parentheses here. And x minus 1 plus 2i, I'm putting parentheses here, so that this you can see it's like a minus b, a plus b. My a is x minus 1, right? That whole x minus 1, pretend it's one object, and the b is 2i. Okay, so that helps me when I FOIL that out. over here, I now distribute x. So x times that, x cubed plus 4x squared plus 4x. And then if I multiply this out, it's x minus 1 squared minus 4i squared. And there's I squared again, which we know is negative 1. So it's negative 4 times negative 1, which is a positive 4. Okay, so we're getting there. So I have this stuff. Okay, this is going to be a plus 4. And now I square this. So x minus 1 squared is x squared minus 2x plus 1. And then I have a plus 4, so that makes it plus 5. So I have x cubed plus 4x squared plus 4x times all of that. And finally, I multiply all of this out. A trinomial times a trinomial, there's going to be 9 terms. Okay, so x cubed times all of that. So that's x to the 5th, negative 2x to the 4th, plus 5x cubed. Okay, now 4x squared times all 3 of these. 4x squared times x squared, 4x to the 4th. 4x squared times negative 2x, negative 8x cubed. 4x squared times 5, 20x squared. Now I do 4x times all of these. So 4x times x squared, 4x cubed. 4x times negative 2x, negative 8x squared. 4x times 5, 20x. Okay, then just gather like terms. X to the 5th. X to the 4th are here and here, both underlined. So negative 2 plus 4 is 2x to the 4th. X cubed I did overline. So what's an overline? It's the opposite of an underline. Underline means that, right? We know underline. So overline is like that. So 5 minus 8, negative 3. Oh, plus 4. So that's just 1x cubed. I circled the x squared, 20 minus 8, 12x squared, and 20x. All right, so that's it for 55, it looks like. Okay, so I'm officially done with everything I need to do. Okay, so what I'm going to do now is sneak in a little bit of chapter 4, not much. I don't think I'm going to do any problems. Maybe just review some stuff from trig. The stuff I'm going to show you right now won't be on Friday's test, of course. It's just to review some ideas from trig for you. Okay, so let me do that quick introduction. But if I have time, I'm going to go back and do some more problems. Okay, so chapter 4 is all about trig, a review of trigonometric functions. And just some basics. Again, 4.1 has nothing. If I put 4.1 in the homework, obviously there's no homework there. Okay. But a quick review about measuring angles, page 195. Okay, we have radian measure. Okay, so we have our famous degree measure, and we also have radian measure. Okay. Now, you might recall if I go all the way around the circle, that's 360 degrees, and it's also 2 pi radians, right? 360 degrees is 2 pi radians. If you divide each of those by 2, the conversion factor is 180 degrees is pi radians. Okay. And if you want to, you can put it on your cheat sheet. Now, don't put it on this cheat sheet for this test. It's the next one. Okay. So you can say 1 degree is pi over 180 radians, or 1 radian is 180 degrees over pi. Okay. How much is a radian? It's about 57.3 degrees. Okay. So you should be comfortable with degrees and radians. Okay. Make sure you know how to switch back and forth on your calculator, right? So on your calculator, you should be able to have different modes. Okay. So on my calculator, there's a mode for degree and radian up here. So radian and degree. So in trig, you have to have radians and degrees. If you have a calculator that looks like this, it's way up here, DRG. D stands for degrees, R is radians. G is something called gradients. We're not going to use that. Okay, so gradients, you can look it up. I'm not even going to spell it, but you want degrees and radians mostly. And so however you can change degrees and radians. Okay, so simple example, you have 135 degrees. How do you change it to radians? Multiply by pi over 180. Okay, 3 pi over 4 radians. Okay. If you want to go from radians to degrees, Okay, you multiply by 180 over pi, 180 over pi degrees, and cancel and so forth, you get 150 degrees. Right? Okay, that's just converting one to the other. Some quote-unquote famous ones that you should know. Okay, so in degrees, 0, 30, 45, 60, 90. 0. 30 degrees is pi over 6, if you can read that. 45 degrees is pi over 4. 60 degrees is pi over 3. 90 degrees is pi over 2. Now, of course, you can always go back and use these conversions, but after a while, when you're using it so much, it is good to have these memorized. Otherwise, it would be kind of slow. Okay, so 30 degrees is pi over 6. 45 degrees is pi over 4. 60 degrees is pi over 3. 90 degrees is pi over 2. Okay. And then in trig, we often use the unit circle. Unit circle is a circle center of the origin with a radius of 1. Right, so that's 1, 0, 0, 1, negative 1, 0, 0, negative 1, and so on, right? Okay, so we will use that a lot in this section. Okay, there are some formulas, and I would say even for now, just maybe listen, but don't even write it down until after the test, perhaps. Okay, length of a circular arc. So if you walk along a circle, how far have you gone? Okay, so here's the formula for that. S, which stands for arc length, is r theta, as long as theta is in radians. Okay, to give you a little proof of this, okay, you know that if you go all the way around a circle, it's 2 pi r, okay, circumference of a circle. If you only have a piece of it, like if you only walk from there to there, it's a fraction. What is a fraction? Well, it's theta divided by 2 pi. The whole thing is 2 pi. You're only doing a fraction. So you take theta over 2 pi times 2 pi r. Notice 2 pi's just cancel out, so you have r theta. Okay, so the arc length formula, S, is r times theta, provided theta is in radians. Okay, and then the other formula, the area of a circular sector. Okay, so suppose you want this, it's like a piece of pie. Piece of pie or a piece of cake that's cut like this. Right? How do you find the area? Well, again, it's a fraction of the whole. Okay? The area of a whole circle is pi r squared. You only have a fraction of it. Okay? The whole thing would be 2 pi. You only have theta. So the fraction is theta over 2 pi times the area of the whole circle, which is pi r squared. And after cancellation, you have 1/2 r squared theta. Okay? So to find the area of a circular sector, the area of that sector is 1/2 r squared theta. Okay? So that's the formula for the area of a sector. Okay? And again, you can put that on your next cheat sheet, not on this Friday's cheat sheet, but on the next cheat sheet. Okay, and as long as I got the page, I'll show this to you for those of you that don't have the book and don't plan on getting it. So 4.2, page 200. Remember, none of this is due Friday. It's not until the next test. So there's the top, and there's the bottom, and some more on the next page, and some more there. Okay, and yeah, that's it for that. Okay. Okay, so now what I'm going to do, yeah, that's all I was going to do for trig for today. I'm going to go back and do a lot of problems from previous sections now. Okay, so this will help. So some of you might have questions today. I might be addressing some of these issues already. Okay, so way back to 3.2, number 15. So I'm doing my own mini review for the test now. 3.2, number 15. Okay, use the zeros and n behavior of the polynomial function to sketch an approximate graph. Okay, x times x plus 1, x minus 1, x minus 2. All right, so here's all you have to do. Okay, the zeros are 0, negative 1, positive 1, and positive 2. So 0, negative 1, 1, and 2. So we don't know about this yet, but put down those 4 points, right? Okay. when x goes to infinity, plug in a big number. Positive times positive times positive times positive. Y goes to infinity. Okay? So I know this shoots out like that. X approaches negative infinity. Plug in a super big negative number. They're all going to be negative, right? So negative big times negative big times negative big times negative big. 4 negative big numbers make a positive big, so y approaches infinity. Okay, so right now for the graph, I have that. Shoots out there, shoots out there. And what about the rest of the graph? All of these are multiplicity 1. So if they're multiplicity 1, they're going to cross the graph. All right, so that gives it to me. This one is up, this one has to come down. And this one is down, that means this one is up, which means this one is down, which I already know that this one is up. Okay, so again, multiplicity 1, you're always going to cross the x-axis. It never stays on the same side. Okay. All right, so that's that. I was asked before about 3.427. Okay, so I'm sort of answering a lot of questions now. You can go ahead and put stuff in the chat if you wish. I might be able to answer some more questions today. But 3.427. Take a look at that one. I can find it. Okay, sketch the graph. Give any horizontal, vertical asymptotes and intercepts. So x squared minus x minus 2 over x squared minus 2x minus 3. Okay, x squared minus x minus 2, x squared minus 2x minus 3. So first you factor. I trust you can factor. X plus 1, x minus 2, x plus 1, x minus 3. And you will notice x plus 1 cancels out. So I have x minus 2, x minus 3. Negative 1 isn't going to be, x equals negative 1 isn't going to be a vertical asymptote. It's going to be a hole. There's going to be a hole in the graph. All right, so I just look at this instead. Okay, so vertical asymptotes, x is not allowed to be 3. So VA, x equals 3. Remember on the test, for vertical asymptotes, you must put x equals 3. Some of you just put 3. It's got to be x equals 3. And my memory trick is VAX, V-A-X, and hey, H-A-Y. Horizontal asymptotes has to be y equals something. So y equals something. So look back at the original, just kind of cover up everything besides the first thing here. X squared over x squared is 1. Or you could do the same thing here, right? Since these are the same except at negative 1, you can just kind of cover up these, and x over x is also 1. So y equals 1 is a horizontal asymptote. So x equals 3, y equals 1 are asymptotes. Okay, so now I just consider what happens when I get close to the vertical asymptote from the left and from the right. I'll just look at this. Okay, so what's to the left of 3? 2.9. 2.9 minus 2, positive. 2.9 minus 3, negative. Positive divided by negative, negative. So shoots down to negative infinity. A number a little bit bigger than 3, 3.1. 3.1 minus 2, positive. 3.1 minus 3, positive. Positive divided by positive, positive. Y shoots up to infinity as I approach x equals 3 coming from the right. So it goes like that, goes like that. Okay, and then intercepts. Okay, intercepts. What makes the, if this function were 0, what makes the numerator 0? 2. So 2, 0. And then how about when x is 0? Put x equals 0. You can put it here. You basically have negative 2 divided by negative 3, which is 2/3. So 0, 2/3. All right, so here's the graph. Goes like so. Gets toward negative infinity, approaches 1, but there's a hole here. Hole at negative 1, 3/4. How to get to 3/4? I plugged into here. See, negative 1's allowed here, but negative 1's not allowed here. So if I plug in negative 1, I get negative 3 divided by negative 4. So that tells me it goes like that. And then I have this breach over here. Okay. let's see, 3.439. Go back and show you that one. 3.439. Okay, x squared plus x minus 2 over x plus 1. Sketch the graph and label the slant asymptote. How do I know there's a slant asymptote? This is second degree, this is first degree. So you have a slant asymptote if the degree of the numerator is exactly one more than the degree of the denominator. Second degree, first degree, or third degree, second degree, or 10th degree, 9th degree. There's going to be a slant asymptote. Let's see if I can show that to you again quickly. Right, page 164. Slant asymptote, where the degree of the polynomial p of x, the numerator, is exactly one greater than the degree of the polynomial q of x. So this is 1 degree higher than this. So 2, 1, or 3, 2, 4, 3, 5, 4, and so on. In our case, second degree, first degree, we will have a slant asymptote. All right, and if I factor, I get this, x minus 1, x plus 2 over x plus 1. Right, the first thing I do is a polynomial long division or synthetic division. Okay, so 1, 1, negative 2, 1, 1, negative 2. X plus 1 means I put a negative 1 here. Okay, 1, multiply, add, multiply, add, negative 2. So how do I read this? 0 plus x, x minus 2 over the original divisor, x plus 1. Okay, so the original function is equal to this. So that means y equals x is a slant asymptote. For very, 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 very big x, either big positive or big negative, this approaches 0. So you essentially have y equals x. So y equals x is a slant asymptote. So when I go way out to the right or way out to the left, the graph gets really, really close to y equals x. Okay, and vertical asymptote, x equals negative 1. Okay, we have no horizontal asymptote, we have a slant asymptote. And intercepts. Okay, so let's check for intercepts. If I put y equals 0, I look at the numerator. Remember, a fraction is 0 when the top is 0. So 1 and negative 2. Okay, so 1, 0, negative 2, 0. And then let me plug in x equals 0. If x equals 0, put a 0 here, here, and here. You get negative 2 over 1, which is negative 2. So 0, comma, negative 2. Intercepts are 0, negative 2, 1, 0, negative 2, 0. Okay, and then analyze what happens when I get near the vertical asymptote, x equals negative 1. Okay, so I plug in, well, you can't see it anymore. Let me recopy it. X minus 1, x plus 2 over x plus 1. Okay, a little bit to the left, negative 1.01. Negative 1.01, that's negative. Negative 1.01, positive. Negative 1.01 plus 1 is negative. So there are two negatives makes a positive. So as I approach x equals negative 1 coming from the left, the function shoots up to infinity. Okay, a little bit to the right of negative 1 would be negative 0.99. Negative 0.99, that's negative. Negative 0.99 plus 2 is positive. And negative 0.99 plus 1 is positive. So I have one negative, means the whole thing is negative, drops toward negative infinity. So when I approach negative 1 coming from the right side, it drops like so. Okay, so we have the whole graph. Touches here, here, and here. That's why we did the intercepts. On this side, drops at negative infinity. On this side, goes to positive infinity and goes toward the asymptote, the slant asymptote, goes toward the slant asymptote like that. Okay, let's see. 3.3, number 9. 3.3, number 9. I'll show you that. Use the factor theorem to show that x minus c is a factor and factor completely. Okay, it's fourth degree. they tell you two of the solutions, right? So once I divide out two of them, I've got it down to a second degree polynomial, and second degrees, you can always use a quadratic formula. Okay. All right, so here we go. Here's the polynomial. They tell you -1 is a 0, -3 is a 0. That means if I plug in -1 and do synthetic division, I get a remainder of 0. Okay, so let me cover this up. Okay, so bring down the 2, multiply by -1, add. Multiply by -1, add, -13. Multiply by -1, 13, add 6. Multiply by -1, add 0. There it is. Okay, I now know this is 2x cubed plus 3x squared minus 13x plus 6. But notice this trick. Since I already have this laid out, I will go immediately to synthetically divide the next number, which is -3. You told me -3 works, right? So it saves writing a little bit. So I go straight to the synthetic division on this. Okay, so 2, 1, -13, and 6. Synthetically divide -3. I'm supposed to get a remainder of 0, and it looks like I do. Okay, so bring down the 2, multiply by -3, add 5. Multiply by -3, 15, add 2. Multiply by -3, 0. Perfect. Okay, so how do I read this now? 2x squared minus 5x plus 2. Okay, so I have x plus 1 as a factor, x plus 3. So right now I have x plus 1, x plus 3, 2x squared minus 5x plus 2, and that looks factorable, right? I mean, how do you get 2? 1 and 2, and you got to end it with a 5. So it looks like we have this. So x plus 1, x plus 3, 2x minus 1, x minus 2. So that's the complete factorization of this polynomial. Okay, and then let's see, 3.313 was asked for. Determine all the possible rational zeros, okay, but don't actually find them. Okay, so that uses the rational zeros test. Okay, so here's how it works. X to the 4th plus 2x cubed minus x squared plus 3x plus 4. So the possible rational zeros are always plus or minus. The numerator is a factor of the constant term. The denominator is a factor of the leading coefficient. You don't care about this one, this one, and this one. In fact, as far as this problem is concerned, you only need to look at that and that, and forget whatever's in the middle. Okay, so the possible rational zeros, factor of the constant divided by factor of the leading coefficient. Well, this is a 1. What are the factors of 1? Just 1. What are the factors of 4? 1, 2, 4. So I have a factor of 4 divided by a factor of 1. Well, if you divide by 1, you basically just have these. Okay, so my possible zeros, rational zeros, are plus or minus 1, plus or minus 2, plus or minus 4. And then you can just stop. You can stop right there. Okay, then 21, factor completely this thing. Okay, it's 4th degree. That means there are 4 zeros. That means you should factor in the 4 terms. Fortunately, one thing's nice is you know right away there's a common factor of x. Okay, so I factor out the x. 2x cubed minus 3x squared minus 3x plus 2. Okay, then what I did, I've already shown you the answer, sort of. But now, sometimes the easiest things to try are 1 and -1. Okay, it turns out 1 doesn't work, but it seems like something involving 1 should work because 2, -3, -3, and 2, maybe they cancel out. Turns out -1 works. If you plug in -1, you get 0. Okay, so I did -1. 2, -3, -3, 2, and -1. All right, so 2 comes down, multiply by -1, add -5. Multiply by -1, 5, add 2. Multiply by -1, -2, 0. All right, so there we go. So two factors are x and x plus 1, not x minus 1, x plus 1. And how do I read that? That's 2x squared minus 5x plus 2. And it seems like we just did that. Yeah, we did do that. So that's just x, x plus 1, 2x minus 1, x minus 2. Right. So fourth degree means there are 4 factors, and there are 4 zeros. The zeros are 0, -1, 1/2, and 2. Right. So remember again the factor theorem. Okay. Fourth degree, there are 4 zeros and 4 factors if you allow for multiplicity, a repeated root, so to speak. Okay. All right, so that's it for that one. Let me see if I have time to do any more on this. Yeah, I was asked for 3.639. Okay, the last section that we had, 3.639. What time is it? Okay. And yeah, tomorrow I'll come up with more questions. Otherwise, I would threaten you to just keep going with chapter 4 stuff, but I don't have to. 3.639. X to the 4th minus x squared minus 6 equals 0. Find all the solutions and factor it completely. All right, 4th degree. That means there's going to be 4 factors and 4 zeros. Okay. One thing about this that's nice, I can think of x to the 4th as x squared squared, right? That's x to the 4th. So it's a quadratic equation in x squared. Okay. It's almost like you pretend the variable is x squared. Okay. I mean, pretend it's at y squared minus y minus 6 equals 0. That's pretty easy to factor. Okay. So if I pretend x squared is another letter of the alphabet, as it were, it's the same as if I said y squared minus y minus 6, or z squared minus z minus 6. So I put x squared and x squared, minus 3 and plus 2. Okay. And if you're not convinced of that, fold it back out. X to the 4th, right? There it is. Plus 2x squared minus 3x squared, that's a negative x squared, and a minus 6. All right, so by the 0 factor property, either x squared minus 3 is 0, or x squared plus 2 equals 0. Move the 3 over, move the 2 over, and do the square root. So x squared equals 3. X is plus or minus radical 3. X squared equals -2, so there's going to be the I stuff. Take the square root. So x is plus or minus the square root of -2. Negative comes outside as an I, so plus or minus I radical 2. All right, so here are the 4 zeros. 4th degree, 4 zeros. Plus or minus radical 3, that's 2. Plus or minus I radical 2, that's 2. And now how do you factor it? It looks pretty bad, but that's all we can do. So x plus radical 3, x minus radical 3, x plus I radical 2, x minus I radical 2. So if you multiply all that mess out, believe it or not, you should get that back. Okay, 3.413. Ask for 3.413. Find a domain, axis intercepts, vertical, horizontal asymptotes of the rational function. Okay, so 3x squared minus 11x minus 4 over x squared minus 1. Okay, let's talk about asymptotes. Okay, so horizontal asymptote, okay, you just cover up everything besides this. So 3x squared divided by x squared, 3. But you have to say y equals 3. Hay, H-A-Y. So horizontal asymptote, y equals 3. Factor. So this factors into 3x plus 1, x minus 4. Okay, I mean, 3x squared is 3x times x. Okay, 4 is either 1 times 4 or 2 times 2. You can experiment, you get this. This is x plus 1, x minus 1, and nothing cancels out. All right, so what's the domain? Domain is all real numbers except whatever makes the denominator 0. What makes the denominator 0 are -1 and 1. So domain is all real numbers minus a set consisting of -1 and 1. Okay. And that means the vertical asymptotes are x equals -1 and x equals 1. And then the intercepts. Okay. If you plug in x equals 0, put a 0 here, here, and here, that means these are all 0. So you basically just have -4 divided by -1, which is 4. So 0, 4. And then plug in y equals 0, put a 0 here or here. When is a fraction equal to 0? When the numerator is 0. So set that equal to 0, -1/3. Set that equal to 0, 4. So here we go. Okay, and the problem doesn't ask for a graph, so I won't graph. And by the way, you should do the same thing. I recognize you only have 15 minutes for the test. So if I give you a question like that, and it doesn't say to graph it, don't bother graphing it. Okay. In this question, it literally said what? It said, find the domain, give the intercepts, okay, give the horizontal and vertical asymptotes, but it did not say to graph it. Okay, the directions did not say to graph it. So don't waste your time on graphing it. Okay, so in other words, if you end up graphing it, don't come to me later and say, hey, I didn't have enough time to do the test. When you ended up graphing it, it didn't say to graph it, right? You waste 10 minutes just doing a graph when it didn't ask for the graph. Okay. All right, so I think that is that. Almost out of time. Let me quickly check the chat. I'm not sure if I have time for anything else. Let's see. Okay, 3.435, 3.643. I'm not sure we have time for those of you that asked it, but you can ask it tomorrow. It depends how fast I can do those. 3.435. Okay. Yeah, I don't think I can get that now. So you can ask it tomorrow. 3.643. See, can that be done fairly quickly? Okay, I think I can do that one. Okay, 3.643. So whoever asked 3.435, ask it again tomorrow. I think we have time to do that. Okay, good. Let me get that one there. What do we have, 5 minutes? Okay, so this may be all I have, 3.643. You have x cubed minus 2x squared plus 9x minus 18 equals 0. X equals 3i. All right, so they tell me x equals 3i. You automatically also have negative 3i. Okay, so let me go x minus 3i, x plus 3i. And there's going to be one more, but at least let me multiply that out. So that's x squared minus 9i squared. And we know that this is -1. So it's x squared minus 9 times -1, or x squared plus 9. Okay, so that means if I divide this polynomial by x squared plus 9, I should get no remainder. Okay, unfortunately, when you have a second degree equation like this, you cannot do synthetic division. We're stuck doing long division, but that's okay. X cubed minus 2x squared plus 9x minus 18. X squared plus 0x plus 9. Okay, so long division. How do I go from here to here? X. Okay, x times this whole thing. So x cubed plus 0x squared plus 9x. Subtract. Okay, that's nothing. That's negative 2x squared. That is a 0x and minus 18. Okay, how do I go from here to here? Negative 2. Negative 2 times this whole thing. Negative 2x squared plus 0x minus 18. And we got it. 0. All right, so that means this original polynomial I can now say is x minus 2, x squared plus 9, which is what? X cubed plus 9x minus 2x squared minus 18. And that works. Okay, so we've got it. So that was a double check. So P of x is x minus 2, x plus 3i, x minus 3i. And the zeros are 2 and plus or minus 3i. Those are the zeros of the function. Okay. All right, we're out of time, folks. So tomorrow you can ask as many questions as you want, and if not, I'll just go do some more trigs. So if you don't want me to do that, then ask a lot of questions in preparation for the test. All right? Okay, that's it, folks. Have a good day. We'll see you later. Bye.